adaptable jet-powered target drone system in use by the United States Navy and Air Force today. This transonic vehicle for weapons system training and evaluation is a direct result of a basic philosophy of the Ryan Aeronautical Company, that the original concept of any system or equipment must contain a growth potential as well as fulfill the initial requirement. The past several years, which have seen the development of today's missile inventory, have witnessed the parallel evolution of the Firebee target system, which has anticipated the requirements of more sophisticated and efficient weapons. Worldwide usage, from Okinawa to Puerto Rico, from Cold Lake, Canada to Florida, plus Project William Tell, the interceptor phase of the 6th and 7th United States Air Force Worldwide Weapons Meets, provide realistic proving grounds for the Q2A Firebee target system. In the 20 days of competition in the 1958 and 1959 meets, the 4756th Drone Squadron flew a total of 157 hot missions with an average flight time of 33 minutes at altitudes ranging from 12,000 to 47,000 feet. An overall mission reliability of 86% was provided by the Q2A system, including all missions, day, night, and multiple launch. Operation Top Gun, the United States Navy's 4th annual air weapons meet, used the KDA-4 Firebee as its target for all-weather and day fighter squadrons. The Firebee demonstrated a previously unheard-of target reliability of 96% during the 4 days of Top Gun competition. The military need to service the newer weapons systems with a higher performance, more versatile target introduced a newer, improved version of the Firebee family, the Q2C. The Q2C is a direct descendant of the original Q2, but provides the system refinements and increased performance capabilities required for advancing weapons technology. It is larger, having a wingspan of approximately 12 feet 11 inches, is 22 feet 11 inches long, has a height of 6 feet 8 inches, and a design gross weight of 2,500 pounds. It is powered by a Continental J69T-29B engine, developing 1,700 pounds static thrust at sea level. On-station endurance is a major factor of efficient target performance, since this determines the number of presentations or missile firings that it may be accomplished on each flight. The Q2C has accomplished a maximum altitude of 59,800 feet and a maximum endurance of 97 minutes, of which 77 minutes were above 50,000. Maximum speed attained has been Mach 0.96 at 51,000 feet. Specification performance requirements are consistently being exceeded in all categories. Reliability is outstanding. During test phase, a total of 80 flights were accomplished with an expenditure of 7 drones, or an average of 11 flights per drone. Flights averaged 49 minutes each. These averages are being continually improved by production drones in the field. Radio command guidance is used in the Q2C system. This has proven to be the most reliable and the simplest to maintain. By means of multiplexing the 10-tone channels of the transmitter and receiver, the system will provide up to 25 channels of command control. The autopilot incorporates all the latest state-of-the-art improvements in transistorized circuitry and miniaturization. The remote flight control box contains all the gyros, as well as the amplifiers and signal shaping circuitry, along with air data and gain scheduling devices. The major functional improvement is the addition of an airspeed optimum climb schedule, which results in 2 significant operational features. The drone climbs from one altitude to another in the least possible time, minimizing range time required and maximizing the on-station time. Q2C auxiliary systems include electronic and optical scoring, visual identification, radar, and infrared augmenters. Radar augmentation in the C, L, and S frequency bands is provided by traveling wave tube amplifiers. Using this augmentation, the radar reflectivity of the Q2C can be increased to simulate a bomber-sized threat to air defense radar operators. Provisions have been included for the installation of radar tracking beacons, which give positive target identification. Infrared targets are provided by flares mounted on the wingtips. Electronic scoring systems have been evaluated and are available. Visual acquisition is accomplished by Ryan-designed, remotely controlled smoke generators and the application of a high-visibility fluorescent skin finish. The Q2C is recovered by parachute. The cycle is initiated in various ways, dependent on target altitude and circumstances. Included is a power-off glide phase, which is initiated after fuel depletion. The target will remain in glide until recovery is commanded. It will also recover automatically if battery voltage drops below a preset level. Glide phase permits the Firebee to be returned to a predetermined area favorable to retrieval. After the target touches down on land or water, the parachute is automatically released to prevent damage by dragging. Retrieval is accomplished by helicopter, boat, or truck, and the Q2C is returned to base for repair and reuse. Fast, efficient, and thorough maintenance is a major factor in the usefulness of the Firebee. This phase of the operational cycle is facilitated by a full complement of ground support equipment, including necessary ground handling, checkout testing, decontamination, storage and work stands, and trailers. Automatic go or no-go self-checking consoles are basic to the ground support system. The entire maintenance handling facility is based upon standard rail transfer units and assembly line methods. The force and Navy acceptance of the Q2C is based not only on the wide missile compatibility, but the adaptability of the Firebee to ground or air launch requirements. Zero-length ground launches, or B-26s, P-2Bs, or GC-130 air launches, fulfill launch requirements for all missions ranging from low-level evaluation and reconnaissance to high-altitude operations in which multiple presentations per mission demand maximum time on station. Surface-to-air missiles designed for point or area defense with low to extreme high-altitude capabilities and with guidance systems ranging from ballistic, infrared, command, semi-active, to active seeker capabilities, find the Q2C a competent target. Air-to-air missiles in either lead collision or pursuit categories have proved their short or long-range efficiency against this same system of appraisal. In order to ensure continuing satisfactory performance, a product improvement program is an active part of Firebee schedules. Expanding the total individual ability of the Q2C Firebee to execute a wide range of tasks, miniaturization of proven radar positioning systems will permit formation flying of Firebee targets, presenting an aggregate assault picture in diversionary assignments. New developments for generating countermeasure signals utilizing the traveling wave tubes normally employed for augmentation are underway. This approach will permit greater utilization of presently available equipment and will eliminate the penalties that accompany the larger, heavier, and higher power-consuming operational equipment. Good basic design, improved maintenance, reliability, testing, and follow-up, and active product improvements ensure progressive efficiency and economy in the field. As a result of all these factors, on any assignment, whether surface-to-air, air-to-air, high or low altitude, against a variety of guidance and attack systems, in execution of a wide range of mission assignments, the Q2C Firebee is an efficient jet target for present and future aerial weapons of all armed services. Because of a basic Ryan philosophy that the original concept of any system must contain growth potential, as increasingly efficient aerial weapons demand a higher performance target, there will always be a Firebee ready for any mission assigned.